Hello, my name is Angela, and in today's video, I'll be providing a step-by-step solution for finding the capacitance in a coaxial cable with a dielectric boundary set up in a series configuration. The first step in solving for the capacitance of any given configuration is to draw a helpful diagram. In the question, we are given that a coaxial cable of inner radius A and outer radius C has a dielectric boundary at a radius of B that runs along the entire length of the cable, as shown. The inner plate has a positive charge, while the outer plate has a negative surface charge. From our diagram, we can collect some important information that will help us solve the problem. The charge configuration confirms that both the electric flux density and electric field are in the radial direction only. Therefore, at the dielectric boundary, D and E are perpendicular to the boundary, and we can say that D1 normal is equal to D2 normal, which is equal to the flux density of the cable. Finally, we can clearly see the capacitor is in a series configuration, as the current only has one path to follow through the dielectrics, and we can assume a total charge Q through the capacitor. The equation for capacitors in series is given at the bottom. The easiest method for solving this problem is to find the capacitance in each capacitor and then calculate the capacitance via the equation shown. To solve for the first capacitance, we must first find the electric field via Gauss's law. We take a Gaussian cylinder of length L and radius ρ and solve for the electric field. We can then solve for the voltage in terms of a charge Q in order to solve for the capacitance, as shown. To solve for the second capacitance, we follow a similar process as presented in the previous slide. This time, we use the second dielectric in order to solve for the electric field. This is labeled as epsilon2. Next, we solve for voltage. The limits of our integral now go from the outer plate C, which is the ground, to the middle boundary B. Again, we can then solve for the capacitance using the given equation. As mentioned previously, the capacitors are in series. Therefore, we can solve for the total capacitance using the given equation. After plugging in the values for C1 and C2, we finally reach our solution. Thank you for watching, and I'll see you in my next video.